Extreme cold events are defined as periods of unusually cold weather that are significantly below the average temperature norms for a particular region and season. These events can involve severe cold snaps or prolonged periods of cold weather. Beneath the celestial dance of southern lights lies Antarctica, a frostbitten expanse pivotal to our understanding of cold weather events. Here, at Earth's frigid pole, the air chills to its very limits, setting the stage for a global climatic pulse that resonates far beyond its icy embrace. In this laboratory of extremes, cold air, heavy and dense, succumbs to gravity's pull, sliding down towering glaciers and rushing across the ice cap. This is the birth of a katabatic wind, a phenomenon as fierce as it is fundamental, propelling itself northward with relentless force. As these chilled winds meet the Southern Ocean, they stir up massive waves and instigate the creation of weather systems of immense power. The cold is not merely dispersing, it is dynamic, actively shaping the climate patterns that will travel toward the equator. Tracked by satellites and studied by meteorologists, these systems are mapped and modeled. Each one tells a story of interactions between ocean, ice and atmosphere, a symphony written in the language of pressure, temperature and wind. As these Antarctic visitors reach southern Australia, their impact is profound. They dictate when we plant and harvest, when we venture out to sea, and how we build our homes. In their icy hands, they hold the rhythms of our daily lives, reminding us that our existence is at the mercy of the weather they wield. Yet, it is not merely a tale of disruption. These weather patterns also rejuvenate landscapes, replenishing waterways and nurturing ecosystems. The cold shapes us, challenges us, but also sustains us, intertwining with our cultures and economies in an intricate dance of cause and effect. From the isolated sheets of Antarctica to the bustling cities of Australia, cold weather events narrate a continuous story of interconnectivity and influence. They remind us that the planet we share is a dynamic, ever-evolving system, with each thread woven intricately into the fabric of life.
Thanks so much to David there for that great introduction. It's great to have you on board with the Sydney Weather Words. So let's hop into it. So why is cold so rare in Australia? And it's really got down to three important factors. The first one is location, location, location. The second one is the maritime battle. And the third one is the climate driver. These are three key things that cold events have to fight with in Australia. The first thing that cold events have to overcome in Australia is actually the location of Australia geographically. We all know that the atmosphere is broken up into a number of cells which drive the atmospheric circulation, and that is the Earth's way of trying to balance the heat and cold. And the first one is obviously that Australia is located right in the join between the Ferrel cell and the Hadley cell, and this causes issues. It's no wonder that we struggle for cold events when you look at our location at the exit point of the Hadley cell and the Ferrel cells, because all we're seeing is dry, warm air, which is the opposite to what cold events are, which is usually low pressure with very cold air. And so automatically these cold events have to fight against the very thing that's trying to block them, which is these high pressure areas. And that's one of the reasons why we struggle to get decent cold events here in Australia. The second thing it has to really push against is the fact that between Australia and the source of cold is a massive ocean called the Southern Ocean. Now, it covers a vast amount of area, and as you'll find out very soon, oceans are very good at regulating climate because of the way they treat heat. And this ocean, the Southern Ocean, is actually a pretty special one because it's also very much linked to the world's thermoline, which is the way the oceans regulate the temperature of both hot and cold. The atmosphere does it through the Hadley cells and Ferrel cells and that circulation. Well, the thermoline is the ocean's way of actually regulating oceanic temperatures. And as you can see from the diagram, the Antarctic, or the Southern Ocean, actually has two major currents: a surface current of warmer water and a subsurface current of very cold water. What this surface current does is it actually keeps the temperature of the water in the Southern Ocean quite stable between 3 to 10 degrees all the time. So automatically cold events have to struggle against the warmer surface of the ocean. And if we look at the period of like the surface temperatures across all that time, they don't vary much at all. And the other thing too is that the Southern Ocean actually is the cesspit or the sewer pit for the dead warm air coming down through the Tasman Sea, which then sinks down into the thermoline and gets transported back towards the La Nina, El Nino zones. The other thing that cold events have to really struggle against is actually a couple of principles of physics. The first one is heat exchange, and water is very good at leaking heat into dry, cooler air as it moves across it. So of course, that's going to erode any cold pool going across that warmer sea surface temperature as it picks up that heat as it heads towards Australia. It erodes that cold pool and obviously lowers the temperatures straight away. The second thing that cold pools originating in Antarctica and having to go across the Southern Ocean has to fight against is that water is extremely efficient at storing and transferring significant amounts of heat without changing its temperature itself. So it can actually store all this heat by still remaining at a constant temperature, which obviously affects cold pools moving across it. And the third thing it has to fight against is obviously a process called latent heat. Now, drier, cooler air going across warmer seas is very good at evaporation, which then of course condenses, forms cloud, which also then releases more heat. So the cold pool is actually eroding itself and fighting itself, even on its way to Australia, which is, there's so many hurdles that significant cold air has to get across to get to Australia, which is why, cold events in Australia are rare, but when they get here, they're quite extraordinary. And last but not least, it actually has to fight warmer air itself. The process of the Earth trying to, balance the temperature budget, dragging all the hot air down from Australia into towards the poles, the cold air actually has to go through that when you have cold fronts or cold events. And so that also erodes and significantly, pushes down the ability for cold air to make it all the way to Australia. So all these processes cold events have to fight through before they even get into our shores. And the last but not least one is, of course, the climate driver, the southern annular mode, which is the La Nina or El Nino of the Southern Ocean. It determines, where the band of westerlies, the lower pressure belt, lies. And if it lies further north, then the cold pools have less struggle because they'll actually get shunted towards a bit of a help get towards Australia. Whereas it's further south, they actually have to fight through more of that Southern Ocean and all the other processes ahead of it. So now you're probably thinking, well, how do we actually even get cold events and all these hurdles in front of it? Well, cold frontal activity is still actually quite an effective way of transporting cold air as the Earth tries to balance its heat budget. You then have the mid and upper level systems, which are actually quite potent at delivering very cold events to Australia because they get to skip the ocean influence and come directly from the upper atmosphere. And then of course you've got our beloved event called the East Coast Low, which can actually drag down very cold air as well and give us a cold event. Looking at cold frontal activity just briefly, we can see that this is again the Earth's way of balancing its heat budget. Warm, hot air is dragged down from the country to balance the budget, and in return, cold air is blasted up. The Next one is our mid-level and upper-level systems. We're going to take a little bit more time to actually look at these because they are very potent drivers of cold weather events, as we've seen quite recently. The number of east coast lows and also snow events have been driven by these upper-level events. And the reason they're so potent is, as I just explained, they get to skip the influences of the Southern Ocean and also that warmer surface air because they come straight from above. And they're linked to what is known as the polar vortex, which is circling Antarctica. Now, this polar vortex is extremely strong and always persistent there. And what happens is cold air actually shears off that polar vortex and flies towards us, and that extremely cold air then destabilizes the air below it, causes these low pressure systems, and of course east coast lows and other strong lows develop off that. Talking about ECLs, we actually have a nice little checklist there where you can see what they look for and how they're constructed. And we have the top 5 memorable cold events from most recent time for you to have a look at. First up on our list is the East Coast Low and Snow event from June 2021. Not sure if anybody remembers that. It was pretty savage. It wasn't so much for rain in the Sydney area as it was for the winds and the surf and cold temperatures. And Sydney Observatory actually recorded its second coldest June date ever due to that ECL. And there's some satellite picture here. You can see that the cold pool is one of those cut off cold pools come up from the polar vortex, initiating the action again and causing the low to spin up. But there was plenty of snow right from the snowies right up through to southern Queensland. Next up for you was a memorable Antarctic blast in July 2015. Tons of snow over the place, plenty of recorded low temperatures across the Sydney area. One of the most striking things about this was actually trying to find any information or satellite pictures about it, which is disappointing that there seems to be that the Bureau has buried quite a lot of cold stuff and there's plenty of hot stuff on their site, which is disappointing, but this was an absolute savage cold outbreak. Next one up from the archives for you was August 1996, which is a classic legendary East Coast low. And what made this one legendary was it bombed basically on Sydney. It pummeled Sydney and the Illawarra with millions and tens of $millions of damage a result. The key feature of this was not only the torrential rain, with many places getting 10 inches within a day, but also was the hurricane force winds that were experienced both in Sydney and the Illawarra. The rail line was cut. There was extensive localized flooding around the place, and there was a lot of damage. This is one of the ones that went down in history as one of the classic ECLs that you'll ever see. One thing I found surprising when researching this was how many cold events actually took place in May. Next one up is the May 2021 polar outbreak, which saw again a number of record low temperatures across the Sydney Basin. Not much wind, just icy cold temperatures. Last but not least was last year's polar vortex blob of cold air. We had snow in early May and it was outstanding. Unfortunately, it was the last cold event we had, or winter almost, but it just shows to show that when that polar vortex gets going, we can see some pretty severe cold weather eventuate. Just before I hand it back over to Sir David to say goodbye and thank you, check out our new Instagram and YouTube channels. Make sure you hit subscribe, turn on your notifications to stay up to date. Thank you so much for your support. As usual, ask questions and have a great night.
In this grand theatre of wind and water, our story culminates as a narrative woven from the icy breath of Antarctica and the vast, tempestuous Southern Ocean. Here, where the cold fronts are born and set forth, we find a global force, a circulatory system vital to the Earth itself. These frigid architects travel beyond their Antarctic cradle, reaching across latitudes and touching lives in unseen ways. They sculpt our lands, dictate our weather, and refresh our spirits. They challenge us with their might, yet offer profound opportunities for understanding and adaptation. As we unravel the complex choreography of these cold weather events, we gain not only foresight but wisdom. With each icy gust and every stormy encounter, we learn more about our planet's delicate balances and our place within them. From the silence of Antarctica's frozen desert to the roar of Australia's vibrant shores, cold weather speaks a universal language of connection and continuity. In its voice, we are reminded of our shared destiny on this blue planet, an ever-spinning globe where the dance of ocean, ice and atmosphere plays on, guiding us into the future with each chilling breath and each whispering wind.